In the study of complex systems, one of the main characteristics is that these large-scale systems spontaneously form what we call emergent patterns. And because those patterns aren't directly determined by the governing equations of motion, we have this problem of discovering these new emergent patterns. And so one of the principal tools that's been developed over the years is to borrow ideas and techniques from the communication theory introduced by Shannon, which goes by the name of information theory. So we use various kinds of information measures to try to describe how complex systems store and process information. It's sort of the best candidate we have for how to diagnose emergent patterns in complex systems. However, after pursuing this for a number of years, the community which has studied this and developed information theory for complex systems came to realize that in fact, there are limitations on the kinds of structure and correlation that information measures can capture in complex systems. So the idea of this workshop, which we convened in May of this year, was to bring together the sort of technical experts in this area for a relatively small discussion group, about a dozen people, to try to lay out what the most challenging problems were, and of course, hopefully have some good ideas to get some solutions. So the workshop, I would say, was widely seen as very successful in laying out the problems, coming up with simplified but clear challenge cases where information theory fails, where we think there are some new arenas to move into, some new ideas. For example, one of the important ideas of late has been that information that's communicated between parts of a complex system, shared information or mutual information, comes in different flavors. So there was a lot of discussion about this particular area called the partial information decomposition, where we're interested in different kinds of information, redundant information, synergenic information that's uniquely transmitted from one part of the system to another. So there was a lot of technical discussion about how to help flesh out this partial information decomposition. There's also a discussion of what kinds of natural semantics or meaning these informational components had. So it was partly the discussions were technical and mathematical, but also we had a number of people talking about applications. So in the hopeful event that we're successful in answering these questions, we can move on to think about meaning in human language, maybe meaning in interspecies communication, more traditional physics and biological problems to study them as complex systems. So the participants felt that the workshop was very helpful in bringing up these challenges. The sort of action items that we came up with, like sort of conclusions, were, well, the problems using information to describe complex systems is very important and very timely and should be continued to be pursued. We also decided as a group to write an essay, hopefully to be published in a high-profile scientific journal, that highlights some of the pitfalls and some of the problems in traditional machine learning, information theory, and statistical analysis that come through these particular problems that we identified in the workshop. So we're now working remotely together to produce an essay that will talk about these different stumbling blocks in even traditional scientific uses of measures of correlation and information.
Yeah.